Chapter 3, Section 6 is about arithmetic sequences and linear functions. So we're going to go over in this section how to identify whether something is an arithmetic sequence or not, and then how we can actually use that information, if it is arithmetic, to kind of see what would come next in the sequence, or what would come in the future, like if we were thinking about an equation of a line. So it is still similar to graphing a line, and being able to use the equation of the line to find any other point that we would maybe want or need for a problem to solve it. First, let's go over some vocab here. So a sequence would be a list of numbers that are in a specific order, and they're going to be separated by commas. Each number that's inside of the sequence is known as the term. So sequences can be filled with terms. Now, most of the time, they're only going to give you a few terms to kind of get you started, to show you what's happening. So, like, what is it increasing by? What is it adding or subtracting, multiplying, those kinds of things. Now, an arithmetic sequence is when you're adding or subtracting the same number repeatedly to create the sequence, where a geometric sequence would be when you multiply by the same number repeatedly. So, for example, an arithmetic sequence might look like this one, 2, 4, 6, 8. So if we think about what would come next, it appears that they're adding 2 each time. So the next one would be 10. Now, this could keep going, so sometimes you'll see like a dot, 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 that follows that 10. To just kind of signal to you that the sequence would continue on after that. They're just going to stop writing it at that point. But if you keep thinking about the sequence going on forever and ever and ever, there's future terms that you may not be able to see or even think about just because it's so far down the sequence. And so a lot of times they'll refer to future terms in the sequence as n. And those would be the unknown terms that are still coming in the sequence, we just don't see them right away. Now, underneath these terms would be their position in the sequence. So 2 is the first, in the first position, 4 is in the second position, and so on. So if you're looking at a term, again, down the line in the sequence, this would be known as in the nth position. Because, again, I could be looking for something that's in the 20th position, or the 30th position, or the 122nd position. So all of those would be signified by the nth position, because it could be changing depending on what I wanted. Now, subscript would be just another way of kind of thinking about where the term is at in the sequence. So you can see the first one is A with a little 1. Then we've got A2, A3. So to write the next couple would be A4 and A5. And to write one that comes beyond that would be A to the N. Again, signifying the nth term, the ones that we don't see. Now, the formula that you see here is you've got A1, and then you've got A1 plus 2, and then A plus 2 times 2. So how are they getting that? Like, where are those coming from? Well, 2 to 4 went up 2. And you're looking then at how did we go from the first term to the 6, and how did we go from the first term 2 to the 8, and then to the 10, and so on. So what you want to look at is you're always going to have the first term, A1, plus your 2, because you're adding 2 each time. So this 2 is kind of what you're adding, or what you would, if it was like plus 3 each time, a 3 would go there instead. And then the number 2 that's next to it, that is from 1 less than the term that you're currently at. So since we're in the third term, I would put a 2 down here. So like this one technically is 2 times 1, because the 1 would be prior to the first term. And this one over here would be plus 2 times 0, because the first term before that would be no terms at all. So if we were to keep writing the sequence here, this next one would be A to the first, or A1, plus 2 times 3, because it's 1 less than the fourth position. Then A1 plus 2 times 4, again, that would be 1 less than the fifth position. So how would we write this generally? Well, you're taking that first term, A1, so whatever the sequence started with, plus 2 times whatever the nth term is that you're at, minus 1. So n could be changed depending on where you're at in the sequence, and then you're always going to subtract 1 from it. Now, if you're trying to find the difference, so if you can't see what they're increasing or decreasing by right away, what the easiest thing to do is to take the second term minus the first term in your sequence, so 4 minus 2, to get that difference, which came out to be 2 for this one. Now, it was easy for me just to see I added 2 each time, but like I said, if you're dealing with a sequence that maybe isn't as clear for you, like just from the eye of looking at it to see what they added or subtracted each time, you can always take the second term and subtract the first term to get what the difference would have been, like what was the pattern. So an arithmetic sequence, again, is when you're adding or subtracting the same thing over and over. Now, a geometric sequence is a little different in that you're multiplying by something over and over repeatedly. So for this one, we went 3 to 6, 6 to 12, 12 to 24, so it looks like they multiplied by 2 each time. So the next term here would be 48, if we took 24 times 2. Then if we keep looking at the subscripts, we've got A1, A2, A3, this would be A4, and this would be A5. Now, for the purposes of this section, we are not going to get into a lot of detail about the geometric sequence. All that you need to be able to do right now is just be able to identify if something is arithmetic or geometric by looking at what the pattern is. Again, if you can't see what was happening right away, take the second term divided by the first term to see what that ratio was. So if I took 6 divided by 3, that's how I got 2. So that's how I knew that I was multiplying by 2 each time. So in order to write out an arithmetic sequence and then to use it to kind of predict what would come next, there's some steps that we want to follow. The first thing you want to do is decide if it is arithmetic or not. So look at the pattern. If they're adding something repeatedly, that would tell you that it's arithmetic. If it's multiplying, then it's not, and you're not going to be able to do the rest of these steps. If it's arithmetic, you want to figure out what the difference is, and then fill in the table that they give you. So fill in any missing terms that you might have, and then use that to help you write out your equation. Now, to write out the equation, we're going to use this form, okay, where an represents the nth term that maybe we're looking for in the future. And then this is similar how we derived that equation for that first example I walked through on the front page there. So we had the first term, A1, plus your difference, so whatever the pattern is, times n minus 1. And again, the n is always going to be there, and then you'll end up simplifying this to actually write the equation to figure out what the arithmetic sequence would be. So after you get it set up, you're going to simplify the formula, and then you may have to use the formula to answer questions. So for example, if I'm given this table here, and I've got my points going 11, 17, 23, 29, I would start to see, like, what are they doing here? So 11 to 17 would be adding 6, 17 to 23 would be adding 6, 23 to 29 would be adding 6. So it appears that they're adding 6 each time. So my fifth term, if I add 6 more to 29, would be 35. And then if I add 6 more again, I get 41. Now, to write the equation, I'm going to pull this up here. To write the equation for the nth term, remember you start with the first term, so A1, plus your difference, times n minus 1. So plugging in these numbers, the first term in my sequence, that goes in for A1, is 11, plus my difference, which is what I'm increasing by each time, is 6, and then times n minus 1. Now to simplify this, we're going to distribute the 6. So we have 11 plus 6n minus 6. And the only thing that you can do left is combine the 11 and the minus 6. So this would leave you with 6n plus 5. So this would be the equation that we could use to represent this arithmetic sequence. And we could then use that equation to help us predict things that are going up or going to be in the sequence in the future. Okay, so for example, there's some follow-up questions down here. If they are asking you what's a term further on in the sequence, you know, you guys could sit there and you could just keep adding 6 repeatedly to find the answer to this, but using that formula is going to be a lot faster. So what we did to find the 12th term is we replaced the n, so I started with this equation, and I replaced the n with 12 because I'm looking for the 12th term. Remember, n in the equation represents the terms future on in the sequence. So I did 6 times 12 plus 5, which would be 77. So if you had sat there and did 29 plus 6, 35 plus 6, 41 plus 6, and then plus 6, plus 6, plus 6, until you got to that 12th term, you should be at 77. Now, if they're starting to ask you, are certain terms part of the sequence, what you want to do is take the number that they're asking you if it belongs and set it equal to your equation and see what type of number you get when you solve for n. If you get a whole number, that means that the term you were looking at or testing does belong to the sequence. If you don't get a whole number, so if you get a decimal or a fraction of some sort, that does not then belong to the sequence. So if they're testing if 92 is part of the sequence, I would basically be putting 92 in for the an term. So if you think of our equation, it looks like that. And we put 92 in for an. Then I would have subtracted 5 from 92. That's how they got 87. Then I would divide by 6, and they got 14.5. Now, that's not a whole number, so it is not going to be part of the sequence. Now, if we test that for 65, again, they do the same process here. They put 65 in for the an term. Then they subtracted 5 from 65, and they got 60. Then they divided by 6, and they got 10. So 10 would be part of the sequence because that came out to be a whole number. So that 10 tells you that it would be the 10th term of the sequence. So 65 would be in whatever the sequence is that I had up there. If I went to the 10th term, 65 should be the number that I got. Now this example here, if you look at what's happening with these numbers, again, went 4 to 20, which is multiplying by 5. 20 to 100 is also multiplying by 5. And then 100 to 500 is multiplying by 5. So this time it's not arithmetic, this is actually geometric. So I'm not able to write out the same type of equation here because we haven't talked about how to do that with a geometric, and we're not going to get into that in this section. We're only focusing on the arithmetic today. What I want you guys to do is practice. So take a look at these two tables, and I want you to decide if it's arithmetic or not, so arithmetic or geometric. If it is arithmetic, I want you to write the equation for it, and then I want you to decide if 84 is part of the sequence or not. So for this first one, I found that in all of these we're adding 7, which tells me that it would be arithmetic. So I filled out my chart here with a 35 and a 42. Now to write my equation, you start with your first term 7 plus the difference 7 times n minus 1. Then I would have simplified. For this one, these 7s are going to cancel, and so we're left with an equals just 7n. So that's your equation. Now to decide if 84 is part of the sequence or not, we should have put 84 in for the an, divide by 7 on both sides, and when I did that I got 12. So that means that it is going to be part of the sequence, so I would say yes, and it would be the 12th term, because I got 12 for my n. Now the other practice problem, when I look at what these numbers were doing, they appear to be multiplying by 3. So this one would have been geometric, not arithmetic. So I can't do all that work that I did on that other problem. So we're going to continue to do this now using just a table to just kind of write out the arithmetic sequence here. So we're just going to kind of practice once again what we were doing and then use our sequence to help us find a term in the future. So from this table here, well, the first thing we need to do is figure out what the pattern is. So they create the formula by finding that difference. So if I look from 9 to 18, 18 to 27, 27 to 36, they're adding 9 each time. So to write the equation, your first term comes from that 9 at the start of the chart. So 9 plus 9 again, because that's the difference that they did. And then times n minus 1. Then they would have distributed the 9. So they had 9 plus 9n minus 9. And just like we saw in that last example, this 9 and the minus 9 are going to cancel each other off. And so you're left with a n equals 9n. Now if I want to find the 10th term, so to do this part of the problem, we would take 9 times 10, and that would give us 90. So 90 would be the 10th term of that sequence. And instead of putting like an n here, you could actually replace that and say a with a little 10, just to kind of signify the 10th term. So I want you guys to practice that here. Create your equation for this sequence, and then find the 14th term. So if I look at what my numbers are doing on this one, it looks like they're adding 16 each time. So to do my equation, we do an equals, your first term was 4, plus 16 times n minus 1. So this becomes 4 plus 16n minus 16. And that simplifies to 16n minus 12. So there's our equation. Now to find the 14th term, I would take 16 times 14 and subtract 2. So 16 times 14 should be 224. Minus 12 should have gotten us 212. The last couple examples I have here are going to take what I just did with you guys, but apply it to a story problem. So it's just going to give you some context of what these numbers are maybe representing. So for example, the sequence 12, 23, 34, 45 represents the total amount a bag weighs after we're adding one newspaper each time. So they want us to write an equation, and then they want us to figure out what the bag is going to weigh if there's 12 newspapers put into the bag. So the first thing I would do is figure out, like, what is the difference here? What's the pattern? So it appears that they're adding 11 each time. So an would be 12 for your first term, plus 11 times n minus 1. So this would be for writing our equation. If we distribute the 11, we would have 12 plus 11n minus 11. And so this would simplify to 11n plus 1. Now if I wanted to find the 12th, or how much it would weigh with 12 newspapers, that's the same idea as thinking about finding the 12th term. I would take 11 times 12 plus 1, which would come out to be 133. And I don't know what the label is, you know, whether that's like ounces or some other type of measurement that they're using, pounds. I mean, I can't imagine that a newspaper would weigh 11 pounds, but maybe ounces or something like that would be what they're adding on each time. So I don't have a label for this one, so I'm just going to leave it as 133. So I want you guys to go ahead and try this problem. So for this one, you need to look for what's the increasing amount here for the length of his jump each time. And it looks like each time they're adding 1.5. So to write your equation, your first term is 8 plus your difference, 1.5, times n minus 1. So this becomes 8 plus 1.5n minus 1.5. And so the equation would be 1.5n plus 6.5. So that's the equation for any term. And they are asking what would be his jump after his 6th attempt. So like, what's the 6th term? So we would do 1.5 times 6 plus 6.5. And that would come out to be 15.5. And again, I'm not sure what that represents as far as distance. It doesn't really say. And so I would just leave it as 15.5 for now, since I'm not sure what the label would be.